Welcome back to Mr. B's Tech Talk. We're examining the fundamental theorem of calculus, and we're going to be looking at a topic called substituting limits of integration. I have a problem here from the worksheet just as a sample for you guys to look at. We're going to take the integral exactly the same way as before, but I'm going to present you with an option that might be easier later on, and that's going to be substituting these limits of integration. And just in case you can't remember, the limits of integration mean here to here. So where are you looking at that antiderivative? So looking at this one, we can see that this is a rational function with a u going to be taken out of the denominator. My du going to be the derivative of that dx. Normally we would divide that too, but we can see that this 2 dx is right here, and the 2x plus 4 cubed is there. So we have the integral being taken. I won't do that yet. I can substitute this in and basically say the same thing as du over u cubed. So the first way that we would normally do this is this first way. We would take the integral, and we could represent this as, remember, u to the negative third. So I'm going to add a power and divide by that power, and I get this right here. And then we usually have the plus c, but this is going to be examined from the interval of -1 to 2. But we have to plug u back in order to evaluate that. So it's going to be 2x plus 4 to the negative second over -2, evaluated from -1 to 2. If you remember what this means, the fundamental theorem, as we said before, where a and b represent the limits of integration, g being the overall function. So we go down here and we take a look at b, and we state that 2 going in for x, and we'll do the whole thing to the power, subtracting and then we get a number, whatever that is. So I'm going to go through with you as just a way we can make this process a little bit easier, and that's going to be substituting these limits of integration. So going back to this step right here, all right, I'm going to go back to this. I'm going to make it still du over u cubed. What we can actually do is take both of these limits of integration and plug them into what u actually is. So just so we can remember, we're basically finding what these numbers are. So this one and this one, my new limits of integration are going to be, well, this one's going to get me 2, and this one's going to give me 8. And the thing that we actually get to do when we change the limits of integration is put them in. And I'm going to rewrite this as this. And you actually just get to take this integral and not have to worry about substituting it back in. So like what we had to do here was put 2x plus 4 in and then do the algebra, and it looks super messy. Here what we can do is actually take the integral and say, all right, u to the negative second over -2, and I'm going to evaluate it at my new limits of integration. So basically all I'm going to have is 8 to the negative second over -2, and I'm going to subtract that with 2 to the negative second over -2. And this looks a lot easier to deal with. You'll get an answer, it's probably 0.1171875. And if we go over here, we can simplify the numerators, and you'll see the same thing. 2 and 2 is 4. 4 plus 4 is 8, and I get 8 to the negative second over -2. Over here, I'll get the same exact thing. That should be negative. So 2 to the negative second over -2, and you can see how this right here is the exact same thing as this, getting me the same answer. And just in case you don't trust me, There's the calculator integral right there. Looks about the same number. And this is the same way to solve it. Bam!